Hey students, it's me, Mr. Fitz. I apologize for my shabby appearance, but it's Sunday, and what do I do on my Sundays but make math videos? I'll sometimes have fun too. All right, well, let me clean myself up here, um, look more presentable for the video. So here we go. There we go. That looks a lot better, right? Now I'm a pickle. Okay, so let me share my screen, and we're going to talk today about slope. So here we go. So slope. Let's take a look. Oh, there's my dog. Okay, here's our slope review. So before we start talking about slope, what I'm going to do is I'm going to look at an example. So what is an equation of the line that passes through the point -1, -6, and is parallel to the line 5x minus y equals 9? And this is the symbol for parallel. Usually you see two like parallel lines. So first of all, what is slope? Slope is the rate of change. And so if I want a line that's parallel to this line and going through this point, so it's some line going through that point parallel to this line. Well, if it's parallel, it's going to have the same rate of change. It's going to have the same slope. So let's figure out the slope of this line, and then we can move from there. So what is slope? Slope's rate of change. So some of you may have learned change in y over change in x. So it's a given change in the output for a given change in the input. Some of you may have learned it as like rise over run. Some of you may have learned this formula, y2 minus y1 over x2 minus x1. I don't like this formula too much just because students often flip the coordinates around and get the wrong sign. So that's a common mistake. So I'm going to show you a way to kind of avoid that mistake. And so the first thing I need to do to find the slope is find some points that are on this line. So what I can do is, function is just an input-output machine, right? So I can plug in some number for x and figure out what the number that is the output for y. So that's what I'm going to do. I'm just going to plug in a 0 for x here and figure out what my y is. So if I plug in 0, 0 times 5 is 0. So what do I end up with? Negative y equals 9. Then I have to multiply both sides by -1, and I get y equals -9. Great. Let's look at one more point. Let's try 1. I'm just going to use easy numbers, right? So I'm going to plug in a 1 for this x here. So what's 1 times 5 is 5. So 5 minus y equals 9. Subtract 5 from both sides, and you end up with negative y equals 4, because 9 minus 5 is 4. Multiply both sides by -1, and you get y equals -4. Let's just do one more. You could stop there, but you only really need 2 points to find the slope. So I'm going to plug in 2. So 5 times 2 is 10. 10 minus y is 9, equals 9. Negative 10, subtract 10 from both sides, and I get negative y equals -1. Multiply both sides by y, and get y equals 1. So I'm going to use these 2 points because the numbers are a little smaller, so it makes it a little easier for me. And so what I'm going to do is I'm just going to figure out the change in x and the change in y. So what I do is I stack my coordinates like this, and it makes it a lot easier to see, all right, well, if I'm here at 1, what is my change in x? I'm going to 2. Well, that's just an increase of 1. So it's a positive 1 is my change in x. What's my change? And that's the little triangle means change, by the way. So what is my change in y? Well, if I'm at -4 and I have to go up to positive 1, thinking about the number line, well, it's just 1, 2, 3, 4, 5. So my change in y is actually positive 5. So what's my slope? It's just 5 over 1, my change in y over my change in x. So for every given x, if x increases by 1, my y is going to increase by 5. So you could simplify that as 5. So now I'm just going to use that slope to go ahead and graph some points. There's one of them. I'm just going to go change in y is 5, my change in x is 1, over 1, up 5. So I'm going to just plot a couple points, plot my line, and there you go. So remember, slope-intercept form, we have y equals mx plus b, where m is our slope and b is our y-intercept. This is in standard form, but this is in slope-intercept form. So now I can write, all right, well, it's going to be y equals, what is the slope? 5x. And where's my y-intercept? Well, it's right here at -1. That's where the x value is 0. So hopefully this is a review for some of you, or most of you. So y equals 5x minus 1. So that's the first part. Let's look at another example. I'm going to show you how you do it a slightly different way, because some of you might be doing this slightly differently. So let's look. Okay, so what is an equation of the line that passes through the point -8, 4 and is perpendicular to the line 2x plus y equals 6? That's what this little symbol here, this upside down t, that means perpendicular. So 2x, again, this is in standard form. It's not in slope-intercept form. So if I can change this into slope-intercept form, then I can figure out the slope of this line, and that's going to help me figure out the line that's perpendicular and going through this point. And I'll show you what I mean by that. So that's what I'm going to do here. I'm just changing this from standard form by subtracting 2x from both sides. And that gives me y equals -2x plus 6. So now I'm in slope-intercept form. And so my -2 is my slope. All right. Now, how do I find the slope of a perpendicular line? Well, the first thing you need to do is you flip it and then change the sign. And that's known as the negative reciprocal. So for example, if my slope is -2, that's the same as -2/1. So if I flip that, that becomes -1/2. But then I also want to change the sign. So that's what's the negative reciprocal. You just kind of flip the fraction and change its sign. That's how you find a perpendicular line. So here's the original point, -8, 4. And what do I need to do? Just use my rise over run, which is 1/2. I'm going to go up 1 over 2. My change in y is 1. My change in x is 2. And I can go ahead and plot all of these points and graph the line. And here, lo and behold, I found my y-intercept. So the equation of this line is y equals 1/2 x plus 8. Now there's another way we can do this. You could just do it mathematically simply by plugging in this -8, 4 into the slope-intercept form. We already found the slope. So it's y equals 1/2 x plus b. So we could just go ahead and plug in this point -8, 4 and then solve for b. That's another way you can kind of go about this. So you don't have to graph it. I like graphing it because it gives me a visual representation. So let's take a look. So yep, I just go ahead and plug in 4, which is my x value. Sorry, my y value. And I plug in -8, which is my x value. And so 4 equals 1/2 times -8 plus b. So I go ahead and add 4 to both sides because 1/2 of -8 is -4. And that gives me 8 equals b. So there you go. All right, I'm going to just pause this 1 second and graph the other line, the original line, so I can show you what the perpendicular lines look like. So here you go. Here's the original line, and this is in slope-intercept form. Y equals -2x plus 6. And you can see here, it forms a right angle. All right, students, just one last thing. So if you can't figure out the sign of the slope, just graph the line and then take a look at it. Remember, this is positive, right? Uphill, going uphill. That's a positive slope. That's a downhill slope. I'm going downhill. Negative, positive, negative, positive. All right. Well, I hope this helps. Please let me know if you have any questions, and thank you so much for watching.